Welcome to the notes on graphing linear inequalities. Remember, inequalities are very similar to equations, except the symbol is different. So just like graphing lines, we must get it in slope-intercept form, which is, again, solving for y. And if you don't remember what that looks like, that's y equals mx plus b. Now, the only difference is instead of an equal sign, we're going to have some inequality there, okay? But remember, we're still going to follow those same rules. Now, there are two differences. All right, we need to know if we're going to use a dashed or solid line and where to shade, because again, there's going to be more than one solution within an inequality. So dashed or solid, here's how I figure that out. If you use a greater than symbol or a less than symbol, it's going to be a dashed line. If you use a greater than or equal to or a less than or equal to, so it's got that equal sign, just like an equation of a line, we're going to have a solid line, just like we always had. So that'll be the same. Now, where to shade? You need to do this for every one, above or below the y-intercept. So we'll always be kind of really keen on that y-intercept because we're having y by itself. So if we use a greater than, all right, or a greater than or equal to sign, all right, either one of those signs, we're going to be above the y-intercept. And if we use a less than or a less than or equal to, anything less than, we're going to be below that y-intercept. So there you have the differences. Now let's take a look at a couple quick examples. So there it is. Y minus 5x is greater than negative 2. So right away I see this no equal sign. I know it's going to be a dashed line. So just keep that in mind. Now we got to figure out above or below. So we got to get it in slope-intercept form. We want y by itself. So I want this 5x to the other side. So I'm going to add 5x to each side. Now when I rewrite this, y greater than. Now I want to write the x first. So that's positive 5x. Minus 2. So that's slope-intercept form. Our slope is 5. Our y-intercept is negative 2. So let's graph this thing. Let's go to negative 2 first. Minus 2. That's our y-intercept. So negative 2 down here. All right, now the slope is 5. Okay, so we're going to go up 5 over 1. Remember, that's really 5 over 1. So let's count that up. 1, 2, 3, 4, 5 over 1. There's 1 point. Remember, you can go negative, negative. So I can go down 1, 2, 3, 4, 5, back 1. There's a point here. So instead of a solid line, it is going to be a dashed line. So you write it just like you normally would, but instead of a solid line, it is a dash just like that. So there's the slope of our line. Mine's not the straightest, but you get the idea. Now I look at negative 2, above or below. So here's my negative 2. It's greater than. So why are the y-intercepts getting greater than negative 2? They're getting greater than negative 2 up this way. So that means I need to shade this side of the line. So all of this over here, I can shade all of this. This is all a solution to my graph. Any point I pick over there would make this inequality true. So again, something to talk about above or below the y-intercept. It's really where the y-intercept's getting bigger. It's on the y-intercepts are getting bigger on that side of the equation. So that's the side we shade. All right, let's take a look at two more quick examples. All right, this one, got to get it in slope-intercept form. And again, I can see here we're going to be dashed right away just because there's no line. So again, quick little note, dashed. Let's get it in slope-intercept form. Let's get rid of this negative 4 by dividing. Now, here's the one trick. Whenever we divide both sides of an inequality, remember that sign needs to flip. So this is going to be y. It was greater than. Now it's less than. There's really a 1 in front of that x, so it's in a positive divided by negative, so it's really negative 1/4 x. And then positive 12 divided by negative 4 is negative 3. So now we're in slope-intercept form. Let's graph this thing. Let's start at negative 3 right here. Okay, now the slope is negative 1/4. So remember, that's negative 1/4 or positive 1, negative 4. Again, you don't want to do negative, negative, that'd be positive. So let's go negative 1, down 1, to the right 4. 1, 2, 3, 4. There's a point. Or we can go positive 1, negative this direction. So up 1, then back 1, 2, 3, 4. Now it's a dash line, so you guys are going to connect it just like this. I'm going to do this in red here. So, all right, there's my line. Now, above or below, it's a less than. Again, this is in terms of the y-intercept. So negative 3, where are the y-intercepts getting lower? Well, they're getting lower down this direction. All right, so we're going to shade all of this below that line. So all of this will be part of our solution. So there you have one with a negative slope. One more quick one. Now, believe it or not, this is slope-intercept form. Hopefully you guys are getting used to recognizing this. It's going to be a solid line. We'll use blue here. All right, now it's x is less than or equal to 4. That is a vertical line. Remember, this is how vertical lines are look. So x is less than or equal to 4. So here's 4. All right, now it's going to be a solid line. It's going to be vertical. So my graph looks something like this. Now this one's a little different. Which side of the equation or the line do I shade? Now it's in terms of x. So which direction is x getting smaller, all right, or less than or equal to 4? So x is getting smaller this way. So when we graph, all of this will be part of our solution. Any point over here, x is less than 4. So all of that will get shaded. So there you go. Have a quick little review on graphing linear inequalities. The big difference, dashed or solid, and then which side of the line to shade. And it's always in terms of which variable it's solved for. X for vertical lines, Y for your traditional lines in slope-intercept form.